Okay, in this lesson, we are going to be looking at some different series, which is basically when you sum up the numbers in a sequence. Okay, so first of all, we're going to look at summation notation, which is that squiggly little um, sideways kind of E looking thing um, that allows you to sum some things. Okay, here's what I want you to notice about the sum. These numbers down here stand for term numbers, okay? All this means is you're going to sum the number from the first term right here to however many terms are up here. It is a term number, not the value of the term. It's you're summing the first term and the second term and the third term and the fourth term, okay? This is the formula for the sequence that you're trying to sum up. Okay, so we'll do some examples so that I think you can see this. If I wanted you to add the numbers 1 to 15, clearly you could go 1 plus 2 plus 3 plus 4 plus da 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 da, okay? And you could add those up. If I wanted you to write this in summation notation, what I would need you to do is I would need you to do something like this. You're going to do a formula like this. This is the first term, okay? So this is A1, A2, A3, so on and so on and so on and so forth. This is A15, okay? And I'm just doing the top row right now. So I am going to sum whatever letter you want to use. I'm just going to use X from the first term to the 15th term. Then what you need to do is you need to come up with a formula for this. This right here is an arithmetic sequence, okay? It's an arithmetic sequence. I am adding 1 every time to get to the next term. I'm adding 1. So I can follow my formula for arithmetic sequences that I used before. That goes like this. And so in this case, my first term is 1. Oops, I forgot the D here. I'm not going to put in anything for n, and my D is 1. If I distribute that 1 through, I have 1 plus n minus 1, which just gives me n. That's my formula for this sequence, which I would put right here. Okay, that's how this would go. I'm not going to ignore the bottom row right now, but that's what it would look like. Okay. Um, when you use the summation notation, you're summing up a finite sequence, something that has an ending point to it, okay? It always stops at a certain number. If you see a sequence that goes, dot, dot, dot at the end, so like 2, 4, 6, 8, dot, 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 and it doesn't stop, then you have to do something special for that, and we'll talk about that in a minute, okay? But, these are for finite sequences that do have a stopping point. All right, so here's another one. Now I'm having you add up all the numbers 7 through 14. Okay? Again, when you do what's called a sigma notation, this little symbol is called sigma. It's also called summation notation. The bottom number is whatever your first term number is. Okay, so this term is A1. It's my first term. This is A2. This is A3. Okay, this is AN. In this case, this is 1, 2, 3, 4, 5, 6, 7, the 8th term. Okay, this is the 8th term up here. Then I'm going to come up with a formula for that. And this is arithmetic, so you can do it several different ways. Okay, you can do it like this, which is probably how you're most familiar with it. So that's what we're going to do. Okay, we are going to do AN is A1, which in this case is 7, that's my first term, plus n minus 1 times D, that's what I'm adding every single time, and I'm adding 1 to get to the next term. So this is 7 plus, if I distribute that 1 through, n minus 1, which gives me n plus 6. Okay, so my little formula over here is just going to be x plus 6. Or if you wanted to use n, that's fine. Again, first term to the 8th term. Sometimes you might not know what term number you're dealing with, and you won't know where to stop. Okay, if I did not know where to stop and I needed to know what this term number was right here, like I couldn't just count it, you might need to take and plug that into your formula. Okay, if I did not know what term number that was, I would plug it back into this formula right here. And so this is the last term that I'm trying to find is 14. My first term is 7. I don't know my term number, and my constant difference is 1. So then I would go 14 equals 7 plus n minus 1. So 14 equals n plus 6. Subtract the 6, and n equals 8. We already knew that because we could count it. But if we didn't know that, that's what we would need to do. We would need to plug this last term in for an, whether it's an arithmetic sequence or whether it's a geometric sequence. That's what we need to do so that we can figure out what term number it was. Okay? Here's an example where they're talking about a corner section on a stadium has 6 seats that's along the front row. So it has 1, 2, 3, 4, 5, 6 seats. And then the next one has 3 more. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 seats. I think you can picture how this is going. So the first seat goes 3, and then 6, and then 9, and then 12, and I keep going all the way up until I get to 24 seats in the top row. Okay, then it's saying, how many seats do you have total in that entire section? Well, I need to know what term numbers I'm dealing with. So this is the first term, the second term, the third term, the fourth term. Now in this one, I certainly could fill out some things and count, okay, till I got to 24 because it's not a super long list. So I can do that. If not, you're going to have to use the method that I just taught you before. Okay, again, use the explicit formula. This is also an arithmetic sequence because I'm adding things, so I could use this formula right here. My last term is 24, my first term is 3, and my constant difference is also 3 because I'm jumping by 3 every time. So if I simplify that, I get 24 equals 3n, and n is 8, okay? So this last term right here is the 8th term. What that means is this. I am going to do my sigma notation. I'm adding up the first term to the 8th term, okay? And then my sequence, I already simplified over here, was 3n. So that's what I'm going to put in right here, okay? That's how I would write that in sigma notation. Now what I'm going to do is I am going to go and stick that into my calculator, which I don't think I did the last time. Okay, so let's do that. When I plug that into my calculator, this is what I have to do. I have to pull my calculator up. Hang on. All right, this is taking a while. Sorry. You know what I'm just realizing? I am just realizing that I messed this up because the first row has 6 seats in it. So we're just going to change this problem so I don't have to redo this all. We're just going to say the first row has 3 seats in it. Okay, I should have started at 6 and not 3. And every successive row has 3 more seats. So we're going to just pretend that that's how it is and that this is our formula. Okay, so now I'm going to go to my calculator, hopefully. And I'm going to go just to my main screen here. And I'm going to show you how to do this on your calculators, okay? So to do this on your calculator, you're going to go math. And then I believe it's down here. At zip. Nope. Let's see. It is Now scroll over to number. Let's try that. Nope. Oh, you know what? I'm in the wrong calculator mode. Hang on, I'm going to the new one. All right, hang on. Sorry. Okay, math. I believe it's down here under 0. Yep, there it is. Okay, so you have to be really careful. So it's 0 right there. Okay, so scroll all the way down until you get summation, and then you're going to define your variable. Mine's going to be x. I am going to go from 1 up here to 8, and then type your formula in. So 3x. Go ahead and hit enter, and it'll spit it out for you. So there's 108 seats in that section. If the first row had 3 seats, and then it went up until there was 24 seats in a row. So when I add this up, I get 105. Okay, what my calculator is doing is it's adding 3 plus 6 plus 9 plus 12 plus 15 plus da 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 all the way till I get to plus 24. When I add all those numbers up, I get 105. Okay, we can do the similar kind of thing with the geometric sequence. So I will show you how that looks. Here is a sequence right here, and we can figure out how this goes here. A geometric sequence will go like this. Okay, again, you're going to start with the first term because this is A1, this is A2, and I know you can count A3, 4, 5, 6, 7, and 8. So this is the 8th term. I'm going to show you how to get that if you don't know that. The formula for a geometric sequence, remember, goes A1 times R to the n minus 1. In this case, my first term is 1. Your ratio, that's what you're multiplying by every single time. So what I'm multiplying every single time by is 3 to the n minus 1. This is the 8th term. Okay, now, if you didn't know that was the 8th term, you would go ahead, take this, plug it into an. So I would have 2187 equals 1 times r to the n minus 1. Okay, I know you don't have to divide by 1, but if there was a number there, you would divide by that. So I'm at 2187 equals r to the n minus 1. Then what you would want to do is you would want to try and figure out that 2187 is a power of something. Okay, so 2187 is a power of 3. In fact, it is 3 to the 7th power. Like that. And then 2187 is 3 to the 7th power. And so then what happens is you're going to sort of make an equation like that. 7 equals n minus 1, and so then n is 8. Okay? Just so you know. So that's how it is. And then you can simply go ahead and stick that into your calculator again. And I will just show you one more time how to do that really quick. So I go to my calculator. I'm on my main screen. I do math. And then I want to get to the 0. Which is right here. Okay, so I hit enter. And again, I define my variable as x. I'm summing up from the first term to the 8th term of the sequence 1 times, I'm just practicing, I know you don't need to put the 1 in, but I want you to practice how you're doing it. 1 times 3 to the, and then x minus 1. Let's see, this kind of got a little weird here. I don't want that there. Okay, let's see what happens when I put it in like this. I think I'm going to need another parentheses. Okay, let's hit enter and see if I get an error. Yep, I do. Okay, I don't want that on there. All right, 3,280 is what I get. Okay, when I stick that into my calculator. All right, then sometimes you have infinite series that you're trying to sum up, okay? And when you do that, what happens is you kind of get some weird things. They'll either go to infinity or they will converge to a certain number, okay? And we'll talk about that in a minute. If you sum up things like 2, 4, 6, 8, 10, and it goes dot, 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 and it goes forever and you add them up, clearly when you add all those up, when I add all up, it's going to reach infinity. And if it reaches infinity, it is a sequence, remember, that diverges. Okay, and it really doesn't make sense to find the sum of it because it diverges and it reaches infinity and there's no ending point. You can't really do anything with it. If, however, you have a sequence that looks something like this, okay, this is a geometric sequence, and this number in here, your R, and when you take the absolute value of it, because sometimes it's a negative number, but if you take the absolute value of that number and it's less than 1, then you know that the series converges, and the sum is going to use this formula right here. Here's where you get your A from, divided by 1 minus R. Okay, so here we go. This is on that same formula. This number right here, which is my R, does have an absolute value that's less than 1. Okay, if it was negative 2.5, it would still have an absolute value that's less than 1. So I know it converges. Okay, if that ratio is greater than 1, it will not converge. And by the way, this is what you look at when this goes to infinity up here. Okay, if you have a stopping point, you don't worry about whether it converges or diverges. But if it goes to infinity, you do worry about whether it converges or diverges. Okay. So if that R is greater than 1, it's going to diverge. If it's less than 1, it's going to converge. And it will converge to A over 1 minus R. Well, our A right here is 2. So it will converge to 2 over 1 minus 0.25, which is 2 over 3/4, which is 2 times 4 over 3, which is 8/3. Okay, so this one converges to 8/3. Okay, so that's how that lesson goes. We're done.